what's the issue with the flat earthers? Well, they raised an issue about a month ago now, and it looks more or less like this. We have a balloon inside a car. The car accelerates, and instead of the balloon going backwards, as intuition would tell you, it goes forward. It's almost scary. Okay, it's like someone pushed it from behind. Okay, this is what it looks like more or less. The car accelerates, and like everything goes backward, including you, but the balloon goes forward. Okay, and the explanation for this is that air accumulates behind the balloon, and because there's more air behind it, that's what's pushing the balloon forward. Okay, so that is the explanation. Okay, and so here, let me show it to you in a different format. This is more or less what it looks like. Okay, we have a car and we have the balloon right there in the middle. As soon as the car accelerates, okay, the balloon, instead of moving backwards, it moves forwards. Why does it move forward? Well, the explanation, the mechanism, is that air moves to the back of the car suddenly, momentarily, and that's what pushes the balloon forward, because there's more air behind the balloon than in front of the balloon. The million-dollar question that I asked, which some people still, or most people still don't understand, cannot understand the question, is what causes the air to accumulate in the rear of the car? That's the question. We're not asking you to tell me, yes, it does, which is what everybody more or less tells me, it does accumulate in the back. No, the question is, what causes it to accumulate in the rear of the car? That's the question. Okay. Okay, so we have a couple of people say, well, what does this have to do with the flat earth? Okay, and here they are. I assume they are flat earthers. Maybe they are flat universers. Okay, so it's one of these two. One fellow says, I'm not sure what this has to do with the flat earthers. And the other person says, this has nothing to do with flat earth. Again, I don't know if these are flat earthers or flat universers. Okay, maybe they take after Einstein. They believe in the W map and Big Bang and all that stuff. Could be one of those. There's another possibility in that they could be electric universers. Okay, and this is what the electric universers essentially believe in. They use vortices, plasma. They think everything's done with electricity. Okay, so maybe these folks are electric universers, and you don't have a problem with electric universers. Because I put them in the same boat essentially as the flat earthers and the flat universers, the mathematicians. I put them all in the same boat. That's 99% of humanity out there. Okay, why do I put them in the same boat? Well, because they make a lot of errors in logic, and they make errors in logic because they never define their terms. That's essentially what it comes down to, what it boils down to. The other one is that they use the same entities, we can call them entities. They use the same words as the establishment, mathematical physics, which they complain against. Okay. Yeah. Okay. So what's the issue? Well, with the electric universers. These are my gripes against them, and that's just in a nutshell. I've talked about them a little more extensively in the past. I'm just going to go real quick rundown of what's specifically wrong with them. Okay, just bullet kind of thing. Blank, 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 blank. There it goes. Okay, so this is it. Electric universers, also known as thunderbolters. They like to use that, call themselves the thunderbolts. Okay, and the first problem is that they theorize that gravity is electricity. Okay, this is essentially their main argument. Okay, that gravity is electricity. And here you have one of them. Okay, he says the following. He says, the electric universe, thunderbolts of the gods, they say, it is not gravity that makes things fall to the earth, as some ignorant astrophysicists might tell you. Aha. Thank God we have some of these people who enlighten us. It says, it is dielectric acceleration between the ionosphere and the earth. Okay, so he's going to accelerate something he calls dielectric, whatever that is. Okay, and so he continues, says, these electrostatic charges are 1 quintillion times stronger than gravity here at the surface. Charges? Well, there's no such thing as a charge. Okay, and so this fellow never figured that out. So he talks about charges, which is a word he inherited from the establishment, the same as establishment that he criticizes, but he takes the same language he got from them. He uses the word charge. There is no such thing as charge, and it's irrational to use the word charge in physics. Okay, Continuing, says gravity takes place between electrically neutral bodies and supposedly causes one body to orbit another. Very amusing stuff. Okay. And yeah, so they do believe that gravity is electricity, and it doesn't stop there. The problem is that they never defined electricity. Not one person in the electric universe understands, knows, what electricity is. They never defined the term. And here you have an attempt made by one electric universer, okay, and he's a big shot at the Thunderbolts project, and he asks, "What is electricity?" And then he says, "Electricity is a catch-all term that describes several different phenomena." Great. Okay, so we don't know very well. It looks like very iffy start. But then he continues, he says, "Electricity, consensus opinion, is lacking precision. Reducing electric terminology into smaller units is impossible because it lies at the bottom of the lexical well." Okay, so the question here is, he starts out by saying, oh, by the way, we don't know exactly what electricity is because it's a semantic issue. That's essentially what he's saying here. But then he continues, says, electricity, which we define as the what? Flow of electric charge, particles of charge. And you look up charge, it's a property of matter that causes it to experience a force. In other words, charge is a property. It's an adjective, not a noun. Charge is a qualifier of something, okay? And yeah, charge is just 1.6 times 10 to the minus 19 coulombs. It's just a value. That's what charge is. And what they're saying whenever they say they move a charge or a particle or of charge, what they're doing is moving a number. They're moving so many coulombs. That's what they're moving. And so, but it says electricity is the flow of electric charge. But then they end up accelerating electricity itself, and we end up with a flow of flows. Okay, it says electricity travels through a circuit continuously. So what do you mean electricity travels? I thought you said electricity is a flow. Now it turns out that the flow is traveling. And then it messes it up completely, saying electromagnetic energy flows. Well, energy cannot flow because energy is a concept. You cannot have a concept traveling. No, concepts don't travel. Things travel. Okay, and then finishes it off saying electricity moves through a DC circuit. And so, yeah, we have all these concepts that are traveling. And yeah, it comes down to them never having defined what electricity is. They have no idea what electricity is, but it's in their name, electric universe, okay? And they have this notion that it's a little ball, which they call charge, and that's what's going to flow. And so they believe that charge is a ball. That's what they think charge is. And so they have these little balls rolling around the circuit. They use the positive and negative signs from the establishment. No one has ever determined what positive and negative mean in physical terms. They just use positive and negative to distinguish one from the other. They could have said A and Z. They could have said north and south, east or west. They could have used any symbol. The fact that you put a plus and a minus doesn't mean that you understand what that plus or minus represents in physical terms. They do invoke the planetary atom. Okay, that's Niels Bohr's planetary model. And so they're going to do electricity, ionization, and maybe even quantum jump. They do it all with this planetary model. Okay, so the problem here is that they borrow a model which is not only ridiculous, right? Because there's no way of showing to begin with why that electron doesn't fall towards the positive proton or nucleus, or why it doesn't spontaneously fly away outside that circle, that dotted circle there. Okay, so to use the planetary model of the atom to talk about electricity is already it's a non-starter. Okay, they think an ice cream cone is a vortex. Anything that they see that looks like that is a vortex. They propose that plasma is a thing. Okay, and no, plasma is not a thing, and it takes an electric universer, a thunderbolter, years and years to understand the argument there. They don't understand why plasma is not a thing. And yeah, it's good luck trying to convince them of what they don't know, okay? And then they use these cosmic filaments as interconnections, as proof that everything is interconnected in the universe. The problem with that is they're going to build their cosmic filaments, their interconnections, they're going to build them with that atom there, which is made of discrete particles. So they have all this connection out there in the universe, and it's all done with these discrete particles. And then the question arises, assuming even that they had it correctly. They somehow imagine it correctly. The question is, electricity, as far as I know, flows one way. And so if it goes from one star to another, which star is the positive, which star is the negative pole? Or are they switching back and forth? Is it alternate current? They never really explain that. So all these filaments that they show as curlicues sometimes when they really zoom in that region, vortex, right? They're supposedly just particles, electrons, moving from one star to another, one galaxy to another, and they create this filament universe. And again, in which direction are the electrons flowing? Are they flowing in one direction first, and then you wait a million years for the electrons to come back? So none of this is really very clear. Okay, with the electric universe, they have a lot of problems. So yeah, I put them in the same boat as flat earthers. There's no difference, and I put them also with the flat universers, the mathematicians who move concepts around, and that's where all these people, the flat earthers and the electric universers, get their language from. They get their language from mathematical physics. Okay? So that's the starting point, which is not very good already for the flat earthers. I consider them all flat earthers. Okay, so if you want to know why this is a flat earth issue, well, now you know. Okay, so here we have one fellow, and he says, the air in the car has a higher density in the back of the vehicle than it does in the front. No kidding. I think he figured this out all by himself. Okay, has he told us the cause? No, all he's got is a description. He's just telling us there's more density in the back of the car. He hasn't told us what caused the density to increase in the back of the balloon. Okay, why is the density higher in the back of the car when you accelerate? That's the issue. That's the question. And he continues, says, this means that the net force on the balloon due to collisions with the air will be in the forward direction. Again, all he's doing is describing. He hasn't told us the mechanism. Okay, so that's not very helpful, because all he's doing is just stating the obvious, that air is higher in the back of the car and lesser in the front of the car when the car suddenly accelerates. Okay, so why did that happen? What caused it to happen? That's the question, the cause, not the description that it does. We know that. We understand that. We want to understand what caused it. And that's where we're having problems getting people to understand the question, the cause, the mechanism, the physical mechanism. Okay? Here's another fellow, and flat earther, and he says the following. He says, a dome keeps it in, and the earth is motionless. The earth being fixed and motionless makes the entire question moot. Absolutely loved it. Okay, so here goes flat earther. Okay, here we have, this is your world, or at least this is what most flat earthers believe in, or illustrate, or, set in motion. Is the sun moving? Is the moon moving? And you can see the moon is moving one direction, the sun is moving in the other direction. If the sun is moving, if the sun is moving and the moon is moving, isn't the earth changing its location with every atom that comprises the sun, with every atom that comprises the moon? So yeah, the earth is moving with respect to those objects because they are moving with respect to the earth. What is motion? Well, first you got to define motion in order to be able to talk sensibly about it. And the problem we have right now is that people have not defined the word motion. Motion, two locations, okay, of an object. So we have two locations. And if the sun is at a second location, the earth moved with respect to that second location. The same with the moon. If the moon moved from one location to another, the earth suddenly changed its location with respect to the moon. Therefore, the earth does move no matter who in the world, in the universe, it says the earth doesn't move. The earth moves as soon as you move, because the earth is moving with respect to you. If you jump, right, the earth suddenly changed its location with respect to you. So if you moved, hopefully the earth moved with respect to you. So yeah, if you want to move the earth, it's very easy. Just jump and you move the earth. Okay, that's how simple it is. Okay, so unless it's stuck on turtles, but that's a different story. Okay, so yeah, the earth does move no matter what any flat earther says. There are no turtles under the earth, and even if they were, we could get the earth to move anyways, because all we would have to do is just jump. Okay, as soon as you jump and run, you're moving the earth in the opposite direction. Again, if I want to move God, it's very simple. God can be in the 26th dimension for all I care. But look at me move God. See, God is changing his location with respect to the tip of my finger. Okay, so as soon as my finger goes up, it's got one location, and God has a certain distance with respect to that point. As soon as I move it down, it's got a different. God's got a different. Every atom in His body, or whatever He is, He's changing His location with respect to my finger. As soon as God changes His location, He moved. He moved with respect to my finger. So not even God, all-powerful God, can avoid moving if I don't want Him to. God going to move whether He likes it or not. I'm going to move Him. Okay. And so, yeah, there's no such thing as no motion, not in the universe. Not in this universe, maybe in another parallel universe. Okay, here's another big brain, okay? All these theorists with big ideas. This fellow says, the video asks, what causes the air to go back? Yeah, correctly. Nothing does. The air stays still. Okay, so far he's got a description, okay? Until it's forced to move by its container, the car. Okay, so far a description. All he said is it moves, okay? Or stands still, the air stands still, the car moves, right? The accelerating interior surface of the car starts accelerating some air molecules. Okay, I guess he's saying that the back of the car is hitting against some molecules and squeezing them against other molecules in front of them so that they all pile up in the back of the car. That, again, is a description. So far, he hasn't explained why. Well, we'll get to that in a second. Essentially, we want to know why some molecules are standing still while the car is pushing the first few molecules. That's going to be the issue. But because it's gas, okay, the average acceleration of the air lags the acceleration of the solid car body, okay? Solid objects accelerate immediately, okay? He hasn't explained why, okay? Gases only accelerate the molecules that are contact an accelerating surface. Again, he's just saying these things. He hasn't explained anything, but then he concludes, he says, how does this not explain what is happening? So he hasn't explained what causes the air to stay behind, the air molecules, before the car touches them or before other molecules of air comes in contact with them. Okay, and I'm going to show that in a minute, okay, in a little more detail. So keep that in mind. Okay, let's move forward here. Here again is this fellow, and he just concludes. He says, the air molecules are accelerated more slowly than the van because they are not in direct contact with the van. Okay, irrelevant, because we're not talking about the ones that move. We're talking about the ones that stand still. They are only accelerated when they next encounter an accelerating interior surface of the van. Again, we know all this, okay? So these people just repeat over and over again that it does, and they think they've got an explanation. The issue is, well, we're going to get to that again. I'm going to illustrate for these people so they understand the question. Right now, they don't understand the question. So here's another fellow with big ideas, okay? Says, why does anyone need to explain the particle not moving? Seems pretty simple enough that the air is, to some extent, just being left behind. There's nothing required to hold it back. It's almost like asking why you stayed behind when your neighbor drove away. Well, it's not exactly like that. See, there's a little bit of a difference, and I illustrated this the other day, but I guess he doesn't have the brain part to understand what I explained the other day. So I'm going to explain it one more time for those of you who have a little more intelligence. Okay, here it is. Okay, here we build a car on top of a tree. Okay, so we built the car on top of the tree. The tree is stuck to the ground. Okay, we got that so far? The tree is not touching any part of the inside of the van. In other words, the bottom part is completely gone. Okay, so the tree is just stuck to the ground, and we built a van over the tree. Okay, that's the situation here. In this sense, the tree is in the same boat as the particle, the molecule of air, or you could say an atom. It doesn't really matter. We have a particle floating inside the van. Neither the tree nor the particle are touching any part of the van. And they're both inside the van. The only difference is that tree is stuck to the ground, whereas the particle is not. Okay, that's our starting point. We're now going to accelerate the van. Okay, what do you think is going to happen? Well, if we accelerate the van, the tree is going to stay behind because it's not touching any part of the inside of the van. It is stuck to the ground. The ground is preventing the tree from moving, okay? And the question is, what happens to the particle? What we are interested in is what happens to the particle. And here it is. So we accelerate the van, and suddenly the tree is left behind. We understand that. It's left behind until it touches the back of the truck, I guess, right? Because it's stuck to the ground, and the ground is preventing the tree from moving. The question is, why did the particle stay behind? These people are saying nothing forced the particle to stay behind. Well, hold it, what forced the tree to stay behind? Wasn't it that it was stuck to the ground? Well, if the particle was left behind, maybe the particle is stuck to the ground somehow as well, or something came in contact with the particle and prevented it from moving forward. Obviously, that something is invisible and intangible, something you cannot see or touch or determine through some kind of experiment. We can't use eyes or hands here. Okay, that's the issue. Okay, so again, the particle and the tree both stayed behind. That's the question. We understand the tree, that's straightforward, but the question is, why did the particle stay behind? Okay, what prevented from moving forward? What kept it in place? Is it also stuck to the ground like the tree? That's the question. That's the $1,000,000 question. These people are saying no. Nothing is in contact with a particle. It just stayed behind. This is more or less like saying, when I do my pencil experiment, right? I let go of the pencil, okay? And it always falls to the ground. The question is, what brought it down? What caused it to come down? And these people are answering, it just does. Well, why doesn't it go upwards? Why doesn't it go to the left? Why doesn't it go to the right? Why does it always come down? And they say, it just does. And they tell you, maybe they tell you it's mass, it's density, it's gravity. Well, that's not an explanation. That's what we're trying to figure out. What is mass? What is density? What is gravity? That's what we're trying to figure out. What causes these phenomena? And they say, well, there's nothing causing it because they can't see or touch anything that's in contact with a pencil. And the question is this something we're going to determine through see and touch? Can the mediator of gravity, mass, inertia, whatever, can the mediator, the one that causes these phenomena, the one that Mother Nature uses, Father Universe, right? Is there something there, something in contact with a pencil, or is it something that we're someday going to be able to see and touch? And so they say nothing is in contact with a pencil because they can't see or touch it. But then they have the irrational definition of the word object, of what a thing is, what an entity is. All these are synonyms, by the way, in physics. Okay, something is there that we cannot see or touch, and therefore the definition of thing, of object, of entity is not that which you can see or touch, because obviously there's something here that you cannot see or touch, which is in contact with a pencil, which is pulling it down, or maybe it's something up here that's pushing it down, but it's got to be a something that you cannot see or touch. That's the issue. And so the question here is, again, here you have the particle stay behind, and they say nothing caused it to stay behind. Nothing came in contact with the particle. Nothing prevented it from moving forward. It just stays there. That's their answer. It just stays there until something pushes it. And so this fellow says, well, it's like, your neighbor leaves you with his car, you stay behind. But it's not the same situation. See, if you're inside the car, inside the van, right, and he moves forward, you will move towards the back. You will be thrown backwards, either because you're pushed backward, pulled backwards, or because you stayed in place and the car accelerated with respect to you. Okay, so this is where we stand. Okay, and so these are the questions we need to answer. And again, it's not the same thing to say that your neighbor's car left you behind, because if you're inside the van, like the tree is inside the van, the only reason the tree stayed behind is because it's stuck to the ground. If the tree were floating in the air, would it hit the back of the truck or not? Would it stay in place, or would it move with the car? And you say, well, if it's sitting on a seat, for example, it'll move forward because it's rigid. Okay, so we're going to make a distinction between that which is rigid, like a steel beam, and that which is not rigid, like liquids and gases, or you. You're not rigid either. So when something accelerates, you're left behind, right? And that's what we're going to get to, okay? Okay, so another fellow just says in there, another flat earther, I guess, says, if the van is moving, the molecule will shoot to the back. So this fellow doesn't believe that it stays still. He says it shoots backwards. Something is pushing it or pulling it backwards to the back of the car. That's what he thinks. So we have all these versions there, okay? Not everybody thinks in the same way. And again, here you have a situation I presented in the past, and take a look at it very clearly, in detail here, okay? You're in the subway, okay? You're inside. Suddenly the subway accelerates. It could be a truck, it could be a train, it doesn't really matter. It suddenly accelerates, and suddenly you feel that you're falling backwards. You're hanging on, but something is forcing you to go backwards. And you say, well, one fellow says you're being pushed back. This fellow, last one. And another fellow might say you just stayed in place and the vehicle accelerated, left you behind. Okay, but it didn't leave your feet behind. And you say, well, it didn't leave my feet behind because there's friction. The feet are in contact directly with a vehicle, with a platform, wherever you're standing, right? And so your feet went forward, but the rest of your body didn't follow through. Well, why? I mean, isn't your whole body connected? And so you say, well, yeah, it's connected, but it's malleable. It's like water. It's like gas. It's not rigid like a steel beam. If I were like a steel beam and and I'm sitting on the platform, I would go completely, my whole body would go forward. But since I'm malleable, the upper part goes backward. But it turns out your whole body is interconnected. You're a bunch of atoms, they're all interconnected. You are connected. Why do you move the rest of your body, except your feet, right? Why does the rest of your body move backwards or stay backward when your feet move forward? That's the question. Okay? Okay, so let's move on here. I did a little experiment. Let me get rid of this. I did a little experiment. People like experiments, so we're going to do an experiment. It's really not an experiment. What it is to illustrate for you the difference between a rigid object and a malleable object. We're going to compare a pencil inside a container, as these people call it. The car is a container of air and of whatever was in there, right? So a car is a container. They talk about the container. We're going to put a pencil inside a container. Now, a pencil is more or less rigid. Its atomic structure is rigid. So when the container moves forward, the pencil does not deform. It doesn't grow big on one end and smaller on another end. There's no flow of atoms, okay? And so here's the experiment, okay? Watch closely. Okay, I'm going to push the pencil. I'm going to push the container containing the pencil, okay? The pencil is just the exact size of the container. I move it forward. You can see there's no change in the structure of the pencil. Just because I moved it eraser first, the tip did not grow bigger, okay? The entire pencil moved together with the container. And so we all say, well, okay, that's obvious. I know that. Okay, so I'm glad you do. Okay, so we know what happens with a rigid object. It doesn't deform, and all the atoms don't pile up at one end. But something different happens when we do it with water. Okay, so here's water. Okay, same experiment. Okay, here's water. And what we're going to do, we're going to push that thing forward, and you're going to see how the water piles up in the back there, and there's going to be a gradient in the water level. And here it goes. I'm going to do it several times so that you can see what's happening. I'm going to push it forward, and you can see how the water immediately piles up in the rear. Okay? Same experience you have. You can try this at home, always in the presence of a relativist, right? And you'll find out that the water goes to the rear, piles up in the rear of the container, which is what we're saying is happening with the air inside the van. And with any malleable entity such as you, when the subway moves forward, your feet, go with the subway essentially because you're essentially stuck to the ground in the sense that there's friction there pulling on the soles of your feet, but the rest of your body doesn't follow through. And so the question is, why is that the case? Why are rigid things different than malleable things such as water and air or you? Okay, so we need to establish what that difference is, okay, to find out why the pencil did not stay back, any atom, whereas the ones of water and air did stay back, remain behind, okay? Okay, so let's look at it in detail here, okay? We're going to go slowly because these flat earthers, man, they're very difficult nuts to crack, okay? So here we go. We're going to show this in slow motion, more or less. I'm going to do a couple of these, okay? Here it is. Here's the pencil, and it's inside the van, okay? And we're just going to put the pencil against the back of the van, some giant pencil if you want to see it that way. And you can see that it doesn't deform. The entire pencil goes forward because it's a rigid object. On the other hand, you can see that the van left a tree behind, okay, because it's stuck to the ground. It didn't take it with it, partly because it's not part of the van, partly because it's stuck to the ground. In the case of the rigid pencil, it moved forward without any deformation, essentially, right? Why? Because it's a rigid object. Okay, so this is our experience. It doesn't deform. Okay, what happens now if we try it with water or air? Okay, well, it's going to be a little different. And what we're going to be looking at is the fact that the pencil, has a different molecular structure, crystal structure, you could say, right? And it's a different molecular structure than water or gas. That's why we call these solids, we call the others liquid, and the other ones gases. Okay, there's a difference somewhere in there. And this is what the differences look like, okay? Okay, this is what these, if you had the eyes of God and you go in there and see it in fine detail, you would see something like this. Now, there's a problem with this. This is from the establishment, okay? And what you see is that you see a ball and stick model here. The balls, we understand, those are atoms, okay? Different kinds of atoms, color-coded in this case. What are the sticks? Well, the sticks are known as bonds. And the question is, what do you mean bond? What is a bond? Is it a physical entity? I mean, what is this, James Bonds? I mean, what are these bonds? And you never get an answer. You won't find an answer anywhere on the internet what a bond is. I mean, is it a physical object? Or is it an abstract concept that the mathematicians use to separate two atoms? Okay, because it looks like all those atoms are interconnected by these bonds. Okay, one atom is tied to another atom. They're bound somehow because of this stick. And in the case of solids, that stick is a little more rigid than in the case of liquids and gases. And so here's the evidence, proof. Everybody wants evidence, proof. Here's authority for you, okay? For all those who believe in authority, okay? Here are different people who talk about it. First one says, space is thought as being threaded throughout with electrical and magnetic tensions. Okay, so threaded throughout with tensions, whatever those are. You can't thread with tensions. You need a physical object if you're going to do some threading. Okay. Another one says a chemical bond acts like a stiff spring. Stiff spring. Talking about an object there. Connecting nuclei. As a result, the nuclei in a molecule vibrate rather than maintaining fixed positions relative to each other. Okay, so there's this bond, whatever bond is, that somehow connects any two atoms there. Okay, that's what they're saying. Another one, a field in physics may be envisioned as if space were filled with what? Interconnected vibrating balls and springs. And yet another one, wiggling one charge causes the field lines attached to it to wiggle. And after a time, the other charge starts to wiggle. It's just like a rope connecting two rocks. The wave here consists of a wiggling line of electric force, which you can think of as being attached to the vibrating charge. Okay, so all of these say essentially the same thing. They're saying that atoms are connected by something physical that they call a bond. But when you look for the word bond in chemistry or in physics, mathematical physics, mathematical chemistry, they don't talk about a physical entity. They use the word bond, bond meaning binding. It binds two atoms together, right? Interconnects them. And one moves the other, meaning there's something physical between the atoms, right? But it turns out that they treat these mathematically. They just talk about what the amount of force is on that bond, what the tension is maybe, but they never identify what the bond is. You certainly won't find these bonds in the standard model of quantum mechanics. So we have no idea what this bond is. What do you mean a bond? What is this bond? Is it a stick? Is that what we're saying? Is it a spring, as they're saying? Something that, moves back and forth, different tensions? Is that what it is? Are we talking about a spring? Or is it just a mathematical concept, an abstraction that they use ad hoc because they need to tell you that atoms react to other atoms somehow? Action at a distance, mediated by whatever a bond is. Okay, this is the issue. Okay, that these people mention the word bond, but you never find out what a bond is. Okay, James Bond again. Okay, so here we have water. We're going to accelerate the car, and you can see how they pile up. The molecules of water or gas, could be air, it doesn't matter. We can do air here, okay? So what these people are saying is that when the back of the car hits the first atom or molecule, right, it pushes it against the next one, which pushes it against the next one, which pushes it against the next one. This is their notion, and they say, nothing compels these atoms, these molecules, to stay in place. It's just that when the car hits it, when the container, the rear of the container, hits them and piles them up, one against the other, that's when they all start to move. That's why they pile up in the rear of the van. That's their argument, okay? So let's look at what they're missing, okay? This is what they're missing. This is what they have to answer. Okay, we're going to move very slowly here. We're going to find out that the atoms or the molecules stay in place until something touches them. And the question is, we're not concerned about the car pushing all the molecules forward or one molecule against the other. We're concerned about why those molecules are staying in place until something hits them, until something comes in contact with them. Being other molecules or the car, it doesn't really matter. But before something touches them, why do they stay in place until something touches them? That's the question. Okay, and these people are saying nothing causes them to stay in place. That's the answer you receive. And again, it's like saying nothing causes this pencil to fall down. It always falls down, Bill. Yeah, I know. I understand that much. The question is, what causes it to come down? There's nothing causes it because I can't see or touch anything. That's why nothing causes this to happen. Okay? So why does it move sideways? Why does it move upwards? Well, we don't know, right? All we say is it always comes down. And the big problem here is that all these people are so used to these things, these phenomena, that it's like second nature to them. So they never question it. Why does the air stay back? They say, well, it does. That's their answer. It just stays there until something pushes it. Okay? It never occurred to them that something is holding on to that thing until something pushes it. Okay? This is the issue. Okay, so here's how we explain this. We're saying there is something holding on to the molecule. We're saying that every atom in the universe is bound to every atom in the universe. They're all physically connected, as you just heard all these testimonies. Stiff spring, binding, the bonds. Okay, those are the bonds. These are the ropes. Those are the ones that bind one atom to any other. We can't see or touch them. We can't run an experiment to determine that they're there, so don't bother. This is a question of imagining, of visualizing what could be holding on to that molecule. We're saying that there are entities that are impinging on that atom. They're binding it to every atom on Earth, as shown there. And so when the van accelerates, you don't need for the van to really come in contact with that molecule to explain why that molecule stayed in place. It stayed in place because something held onto it. And those are what we call the electromagnetic ropes that interconnect every atom in the universe and which interconnect that molecule to every atom on Earth. That's the explanation we give. Okay, that's why it stayed in place. That's what held it in place until the back of the car hit it. And again, we have to put Mr. Muller, Richard Muller. Again, we put him on, and people are not listening. They should listen to Mr. Muller because he's telling you like it is. Okay, so here it goes one more time. Listen carefully.
What's the force of gravity on me? It's the pull of the Earth on my body. So, for example, if you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. On the other hand, there are a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
Okay? Do we understand what's going on here? Okay? We're saying that every atom on Earth is being pulled or connected to every other atom on Earth. Okay? And like Mr. Muller just said, every atom of you is pulling on every atom of the Earth. Every atom on the Earth is pulling on you because gravity goes right through things. And I don't know if that's sunk into the head of any flat Earth or flat universe or electric universe. Every atom, let me repeat that. I'll repeat it 100 times if necessary. Every atom in your body is pulling on every atom on Earth. Every atom on Earth is pulling on every atom of your body. What part don't you understand? Okay, how do you pull if not with some elongated object, a thing? If you say there's nothing here and this just falls to the ground, you're saying this is done by black magic. Action at a distance is black magic. You have no explanation. If on the other hand you say, look, every atom in this pencil is bound to every atom on Earth, then we can see why this falls to the ground, because as it falls, all those ropes, open up. And as they open up, the acceleration is greater and greater and greater. That's the mechanism. Now we have a mechanism for gravity. Okay? And so the question now again is the same for our little atom there, our little molecule. It's being held in place, more or less. I mean, it is moving around because air does move around. Okay, but they're all more or less held in a region. They don't move as fast as a car in one direction, especially not sideways. If anything, they're being pulled downwards. There's a flow of air inside the car. But all of them are stuck to the every atom on Earth. Every atom of the molecule, or atom, let's just deal with atom. Every atom of the every atom of the air is being pulled by every atom on Earth. The Earth also pulls on it. Okay, so one is pulling on the other. In other words, there's a tension between them. That's more or less what keeps it in place when the car accelerates. Obviously, the air does not accelerate as fast as the car, as people have mentioned, and that's why the container ends up hitting and piling up all these atoms towards the back of the car. Okay, so now we have a mechanism because there is a physical object that is holding on to the molecule until the back of the car piles them all up against the back of the car. That's the explanation. Okay, so let's apply Muller to the rope model. Here we have it, okay? There we have it. Every atom on the Earth is pulling on every atom of you. You're also pulling on it. And the amazing thing about gravity is that it goes right through things. So there you have it. That's the reason the molecule stayed in place, because it was held there by all the ropes that are converging upon it from the Earth, from you, from everything. And yes, it does move. It still moves a little bit, but not as fast as the car. That's the issue. So they more or less get piled up once the back of the van starts piling them up towards the rear of the car. Okay, you still don't believe. Let's put some more evidence, okay, of how things are interconnected. Here's another fellow you must have heard of someday. His name is Brian Greene. And this is what he has to say about interconnectivity out there in the universe, okay? The problem is some of these people don't pay attention to what he's saying. In fact, Brian Greene doesn't pay attention to what he's saying either. He just, without any cause or reason, he dismisses interconnectivity after saying that it is like if everything were connected. And here it is.
How does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope.
They behave as if they're connected by some kind of invisible rope. They behave as if they're connected by some kind of invisible rope.
But everyone knew that wasn't true.
So, do we have interconnections between the moon and the Earth? Do we have interconnections between you and the Earth? Do we have interconnections between the molecule inside the car and the Earth? And the answer is yes, because if you don't put an interconnection there, you're going to explain those phenomena with black magic. You're going to say, it just happens. It happens from action at a distance, whatever that is. It's mass, it's density, it's gravity. Those are concepts. You can't say, that's what we're trying to answer. You can't say density caused this to happen. Gravity caused this to happen. Mass caused it to happen. Force, energy. You can't use any of those words. Those are concepts. You got to tell me what physical object is in contact with a molecule. Otherwise, you're doing black magic. You can't replace objects with concepts and say, I'm going to do it with a concept. That's where the problem is. And that's how mathematical physics does it. They do it by introducing concepts such as field, force, wave, whatever. Those are all concepts. Yeah, those are not physical entities. Okay, so now you know what the question is. You got to tell me what physical object is in contact with a molecule that stopped it there, which retained it there, which made it stay there, which forced it to stand still. Okay, that's the question. Okay, here's another flat earther. He says the following. He says, we do not actually know that the physical Earth is rotating. We do not know that the physical Earth is a globe. We are told it is, but there is no science test, direct measurements to confirm either of those directly. Curve of the Earth isn't actually checked. There is no explanation as to how to test it is true in the real world, if it is true in the real world. There is no direct evidence that water ever curves. Okay, so we have a problem because this person is talking about, running a test of some kind of measurement that he wants. He wants to verify. He wants to check it, test it, experiment. And you can't use any of those. Those all belong to religion. Okay. So whenever you use the word know, test, measure, confirm, all those at the bottom there, convince, convert, persuade, you're talking about religion. Okay, so all this person wants is religion. He wants someone to convince him that the Earth is round. And I'm not sure what he wants as a test. What kind of test? He says, I'm going to measure it. I'm going to walk the, all around the Earth to find out if I come back to my starting point. I don't know. I don't know how he's going to prove to himself, with some kind of experiment that the Earth is round. And, the way we look at it is here we see it. This is how we prove that the earth is round. If all atoms are physically interconnected, if they're all bound to each other, then we can see why both water and air curve around the earth spherically, spherical earth, right? So this is a spherical shell that's enveloping the earth. That's air there. The dark blue is water. It's all roundish. Why? Because all atoms are pulled towards the center of the earth. Every atom in your body is pulled by every atom on earth. Every atom on earth it pulls on you and you pull on it. That's the situation. Okay. So until you get a handle on that, okay, let me get these out of here. Until you get a handle on that, you're going to be spinning your wheels. You're going to say it's all done with nothing, with concepts such as mass and density and who knows what else. No, you got to put a physical object. Physics, first and foremost, is a discipline that deals with objects. Without objects, you can't do physics. Imagine there were nothing in the universe. What would be happening? What experiment would you be running other than you? You're the only object, right? What would you be doing if there's nothing out there? Now, you need to have objects to do physics, and there are invisible, intangible objects that you will not be able to elucidate. You will not be able to zero in on them by running any kind of experiment. Experiment meaning eye, hand, right? You can't run an experiment to detect that which is invisible, intangible, which is what Mother Nature uses to do gravity.